This is Kamal. I'm co-founder at AccelerateAI. I welcome you all to this session. We'll be focusing on unsupervised machine learning and very specifically association technique as part of this session. So let's dive in. If you look at the problem of identifying purchase pattern of customer and what goes in that, then we try to understand how association rules are related to it. Think of a scenario when you go out to the supermarket store with the intention of maybe getting milk, but are instead presented with more options like eggs, bread, and so on. You feel that the need to spend a little more and buy those two inadvertently. You might seem to think you made a decision to buy those and it was solely on you. However, the placing of objects in the aisles is done in a strategic way and it encourages you to explore the store until you have bought more than what you need. So let's understand how this is happening. And this is a classic example of market basket analysis, kind of a association rules, which we call, and we'll talk about that. So as part of today's agenda, we'll be focusing on quickly on the premise and the motivation of unsupervised machine learning and how does it help into these kind of uh, problems that we face in business. Then we will talk about the market basket analysis. We understand the association rules, then different measures to validate those rules. There are certain measures such as support, confidence, lift, and leverage. We'll talk about those. Then we'll talk a little bit about methods and algorithms used for complex scenarios. A priori algorithm is one of the key algorithm, and we'll talk about that. And then, of course, we'll latch on to a quick demo of an association rule implementation using a Python notebook. When you look into unsupervised machine learning, now this is something which is where algorithms that learn from unlabeled data, right? We have supervised, unsupervised, and reinforcement learning. The unsupervised one where the algorithms learn from the unlabeled data. There are different techniques as part of it. One could be clustering, association, anomaly detection, recommendation, and so on. If we look at specifically, let's say a clustering, you're trying to group by certain behavior and try to cluster, categorize them. Whereas when you look into association, the scenario is different. You're trying to identify people who buy X, they tend to buy Y. People who buy P plus Q, they tend to buy R. So that's what we are trying to uh, kind of understand as part of it. And that's where association will come into picture. Let's take an example. You'd have noticed these recommendations while making your purchases, right? Some of the examples of these are very practical in nature when we look at it. And if you talk about something like a mobile cover, then obviously it is prompted with the added cover of some of these that have been frequently bought together. If we are talking about a coffee maker, then the sandwich maker along with the juice maker is going to be proposed or recommended. So that's typically what we have seen, right? So that's an example which we can correlate to association. Similarly, if we go historically, this famous example of beer nappies case, the story of correlation between the beer and diaper sales is very, very common to explain the product affinities in data science. Now, what has happened is the analysis of some of these purchases revealed that they were made by men typically in the weekends around Friday evenings from 6 p.m. to 7 p.m. And the retail stores where it was found, they have found some very specific rationale behind it. One, since the packs of diapers were relatively large in size, the wife, who in most cases made the household purchases, left the diaper purchase to the husband for their babies. So probably they have gone and picked it up. That could be one rationale. Second, being the end of the working week, the husband and then the father also wanted to get some beer in for the weekend. That's probably the background of it. But what they did, that they put the premium beer display next to the diapers. So it's kind of an upsell, right? So you're upselling your other product, which can be correlated. The result was that fathers buying the diapers who also usually bought beer, as it was so conveniently placed next to the diapers, so that the upsell happens more in a seamless manner. Significantly, when we look at men did not buy beer before, began to purchase it because it was so visible and handy just next to the nappies. So it's kind of a cross sell as an example. So net result is as beer sales skyrocketed. So this is a classic example of how historically this has happened, and an example of the association. And that's where the market basket analysis as an example is what it is. So what questions are we trying to answer as part of this, right? We try to look into what combination of products that are usually brought together, right? So you look at some examples like where should we place the detergents in our store to maximize the sales, right? Are the window cleaning products purchased when people buy detergents and orange juice? If that's a kind of analysis that we are getting in, then we can actionize our steps accordingly. As a store manager, store owner, they can actionize it appropriately. Another question of example could be, are the canned soft drinks purchased with bananas? Now, does the brand of canned soft drink make a difference? Then accordingly, they can plan and actionize that way. How are the demographics of the neighborhood impacting the customers who are buying this? Right. So a lot of these questions, when we look at it, it looks into the combination of products usually that bought together, and which is what is the premise of it. Now, let's take an example. When we look into a point of sale transaction, which is in this case represented with 5 different transaction IDs, these are all called market basket transactions, right? So let's say the first transaction, you have bought the bread and milk. The second transaction, you have bought bread, the diaper, the beer, and the eggs, and so on, right? So this is an example of market basket transactions, each having transaction IDs and a set of items that we kind of buy as part of it, which is what is captured here as an example. Now, what is a frequent item set, right? We can't really go with a brute force approach. Frequent item sets is like why, the combinations of the items that are presented, right? We'll have to start looking at it, what is happening here. So there, if you look at it, the frequent item set is nothing but the unique set of these. And then there are how many such unique items? 6 unit items. If we look at in the set of 5 transactions that we have considered as part of this example. Now, what's happening is there could be 2 to the power 6 or 2 to the power t item sets possible, where t is the number of unique items. So total possible item sets here, you could imagine 2 to the power 6, which is 64. And that's a lot, with just about 6 unit items when we consider as an example, right? Now, few example of the item sets could be, you can consider bread along with milk, bread along with eggs, and then milk with diaper with beer, then milk with diaper. There could be a lot of these different combinations possible, right? However, what we call a frequent item set is essentially whose occurrence frequency is more. So in this case, if you look at diaper and beer, diaper and beer is appearing in 15002, transaction ID 15003, and also in 15004. So there are 3 occurrence of both together. That's the frequency, occurrence frequency. Hence, it is a frequent item set. Now looking at what is an association rule. In the same example, when we look at this as a market basket transaction, then what we're trying to see here is if beer, if diaper, then beer, right? That's an example of an association rule. If you are buying diaper, then you are buying beer. Now, emphasize here is on why the association, right? Why are we saying diaper, if diaper, then beer? Why not if beer, then diaper? Because if you look at in this set of transaction set, wherever you have beer, you have the diaper that is available. So it's all preceded based on this transaction set. Whereas here there is a diaper, but there is no beer. So which means if it's the reason, because if there is a diaper that we are purchasing, then it so may happen that we are buying beer as well. But there is no proof of if there is a beer. If there has been no diaper in that case, then we would have considered that a scenario, but that's not a scenario. So hence the association rule, the if and else, when we look at if diaper, then beer. So if then kind of a antecedent and consequent, which is what is the association rule, is what we say. So measuring, when we measure this association rule, the terminology is what we are saying if then. If part is your antecedent, which is A, B part is your consequent, which is B. If diaper, then beer, right? And there are certain measures like support and confidence. Here, if we look at support is 60% and confidence is 75%, we will see how that is being calculated shortly in the next few slides. Now, diaper and beer are sold together 60% of the transactions. That's what support means. Out of your 5 transactions, 60% of the transactions, thrice we have seen both are sold together. And in 75% of the cases, when someone purchases a diaper, a beer is also purchased, right? So that's the correlation. In order to discover some of these measurement rules or principles like support, confidence, and all, we have to first convert the point of sale transaction to a binary matrix format from a data representation standpoint to analyze this. As you would see here, what we have done is we have converted this from a transaction ID to the nomenclature of each of these, like bread, milk, diaper, and all that. And then against each transaction ID, if it exists, then there is a 1, else there is 0. So we know very clearly the kind of a conversion of this binary matrix format. You have to do that first, and then let's look at what support means. So support of diaper here means that you have all occurrences in the antecedents and consequences divided by all transactions. So which means, your diaper is actually 4 times occurring out of the 5 transactions. So 4 by 5, the support of diaper is 80%. Because if you look at it, it's appearing in 15,002, 3, 4, 5. It doesn't appear in 15,001, right? Similarly, support of eggs is just twice out of 5. So 2 by 5, 40%. Now, if we take multiple item set, let's say support of diaper and beer together, if we consider both, then wherever we have both of these as 1, there are 3 such cases where both of these are 1. So the support of diaper and beer is 3 by 5, which is 60%. Similarly, support of milk and diaper is 2 by 5, which is 40%, because it's just appearing 1 is appearing 2 times together. Otherwise, 1 0 0 1 0 1, these are not considered here, right? So that's about the support. Support is the all occurrences in antecedents and consequences taken together, summarization of that divided by all transactions in the database that we're considering. When we look at confidence, confidence is essentially we have the support factor, which is already measured. Now, confidence, when we say from X to Y, confidence of the fact that someone, when he or she is buying diaper, he or she will buy beer, then we will go by the formula of support of X intersection Y divided by support of X, which means the transactions both where antecedent and consequent item sets occur, divided by the transaction with antecedent item set. Now, if we look at that, then for support of diaper and beer is something which is diaper and beer is 3 times out of 5, which is 60%. And support of diaper itself is 80%. So 60% by 80% or 3 by 4, that's 75% of confidence of diaper to beer, right? So that's what confidence is about. When we come to lift, lift is essentially nothing but lift of x to y. It's like a support of x intersection y divided by support of x multiplied by support of y. So here, if we look at, we have, we are going to calculate the lift of diaper to beer. And that's for that to happen, we need to have support of diaper and beer, which is 60%. We have already calculated earlier. Support of diaper is 80%, support of beer is 60%. So it's 0.6 divided by multiplication of 0.8 into 0.6, and that comes out to 1.25. So higher the lift value, the stronger the association between two items. That's the interpretation. Then there is something called as leverage. Leverage is nothing but how many times more often X and Y occur together than expected. Are they related or coincidental? That's what we're trying to, gauge from leverage. And here, similarly, considering the formula of X to Y of leverage is nothing but support of X intersection Y minus support of X multiplied by support of Y, which is where you get the value of leverage. So we have talked about the measurement factors of support, confidence, lift, and leverage. So the need for specific methods or algorithms will come to picture because we have seen this 4 different rules of measures, right? Or measures of rules. Now, it's difficult to solve when the items increase because we have seen 6 item sets, unique item sets, and it could create 64 item set occurrences. And of course, you have to find out the frequent occurrence of the item set and so on. So the problem is when it is so large, we can't really go and manually solve it. So hence, we would need algorithm to solve this complex problem. There is a need to solve this at a larger scale. That's why we have that. And another aspect is when we look at something like confidence, it can identify trustworthy rules, but it cannot tell you if the rule is coincidental. So we need to understand where it is related, where it is coincidental. So from all that factors, it's important to go into an algorithm, and that's where we get into something called as a priori algorithm. It's an algorithm for frequent item set mining and association rule learning over relational databases. It proceeds by identifying the frequent individual items in the database and extending them to a larger and larger item sets as long as those items appear sufficiently often in the database. That's why we use a priori algorithm. And if you could see that the frequent item sets determined by a priori can be used to determine association rules, which highlight general trends in the database. And this has applications in domains such as market basket analysis and so on. And here, if we look at the algorithm or at a high level view of it, you would see we have considered 4 items, A, B, C, D. So to start off with, the way it works, it generates K item sets, as part of it for K products. First, it sets the minimum support criteria. Then it generates a list of 1 item sets that meet the support criteria. So it starts with null, then identify A, B, C, D individual items, and then it uses the list of 1 item sets to generate the list of 2 item sets. So for example, I have A, it'll start creating AB, AC, AD, right? Similarly for B, AB is already there. So, it could be B, AB is already there. So BC, BD, that's all, right? So that's how it gets created. Then it uses the list of 2 item sets to generate list of 3 item sets. It could be uses AB to go for ABC, ABD, because that's where AB is involved, but C and D are the other item sets and so on, right? And then of course, last one is ABCD where it's only one. So that's how it continues up through the k item sets and it creates, and a priori typically invoked with a minimum threshold support of zero point 0.1, but that can be used appropriately. Similarly, there are other algorithms. We will not go deep into it, but frequent pattern growth algorithm is the intuition here is, frequency can never increase when we add a new item. It can only decrease. So this is called the downward closer. And that's where the objective of finding descriptive patterns with probabilities that exceed a certain threshold is where we use frequent pattern algorithms. Similarly, there is something called as equivalence class transformation. It represents data in a very vertical fashion. It's slightly different. It searches in a depth first search principle approach, and this is another algorithm as well. So if you look at a priori FP growth and ECLAT, all of these three a priori is something which uses the breadth first search. It is tree-based, it requires multiple database scan, and it is suitable for large databases and generate the frequent item sets. That's how the principle is. And then others are slightly different than that. So let's get on to the demo using the notebook. We will jump on to the notebook now. Okay, so hope you're able to see this. When we start looking into the notebook, what we typically do is we import all required libraries. We have considered a groceries data set for market basket analysis as part of this example. This is available in Kaggle and other places. What we need to do is what we have done here is something like ML extend package, very specifically used for market basket analysis. And we are using for pre-processing, we're importing 1HUD. And for the frequent patterns from ML extend, we're importing a priori and association rules. And then, of course, some of the data visualization related stuff, and then NumPy and pandas. So we have read the data and organizing it. When we start reading it from the CSV file, we could see there are different type of elements like citrus fruit, tropical fruit, whole milk, all of these things that we have. Then we would like to stack the data frame to get all unique item sets by value. So it does a representation in such a way that, we have the values like this represented, and then we encode them to a transaction, because we've seen from a point of sale to a binary kind of a format where we want to have all of these one hot transactions, kind of a cross tab where for each of the row item, we have the value or the name of the item like baby food, bags, baking powder, and then the binary value of it, whether it is existing as part of that transaction ID. So here, as you would see as a sample data set, we have kind of 5001 rows and 168 such columns that we have. Then when we try to capture the frequent item sets, we will use a priori the data frame that we have. Then we have used a minimum support of 0.02, and you can use column names true. And then verbose one will show you this processing how many combinations and what is the sampling item set size. It shows that. And then when we do initial few rows of the frequent item set with the support value, it shows us the item set and the support of it. Then we sort the values by support. Then we get that based on the support value, what are the item sets are attached to it. So in this case, let's say whole milk and frankfurter is something with 0.020196 and then so on. Then we try to get the support, the frequent item sets. We sort the values by support and in an ascending order, so that the whole milk is having the highest support, and then it follows by that. So then we use, kind of generating the association rules from this frequent item sets. Now we have the a frequent item set which is created and is available with us, then we'll use the rules, where we'll use the function association underscore rules. And then we take the item sets, the frequent item sets, then we say what metric that we are going to use. Is it lift? Is it something else? So we are using lift here with a minimum threshold of 1. We don't want anything which is below 1. We just want everything which is above 1, so that we get those item sets. And that will give a kind of a sample of top 10 records where we see antecedents, consequent. So this is your A, then B. If A, then B, right? If you're buying yogurt, then you're also buying tropical fruit, that type of thing. And then for each of these, you have an antecedent support, you have a consequent support, you have an overall support, then confidence, then lift, then leverage. There is also something called conviction. So there are a lot of these parameters. So the measures are kind of represented as part of association rules when we use this. Then we can always change the metric to confidence and set the threshold, whatever we want. And based on that, it will show accordingly. So we can play with the same data with a different metric and a certain minimum threshold. And we can, the result of that association analysis will indicate which items are purchased with which other items frequently. And of course, with higher support or higher confidence, or a higher lift, and all that stuff that we can measure accordingly and represent in this view. We can also do a chart, kind of a scatter plot between these metrics like support and confidence. When we plot that, we see the values of support and confidence. And here are some of these items with the X and the index values there. So you'll have an understanding of how many item sets that we are looking at. If 0.15 is the support and 60 is the confidence, 60% is the confidence, then we are looking at something like this, right? So similarly, we can also look at the support versus lift. So this is support in x-axis and lift in y-axis, and accordingly we can look at that. Similarly, lift versus confidence also, that we can look at it, and that will give this is again a representation of kind of a polynomial representation of line to see how it is represented, the values across these two as a scatter plot. So that's about it. And we have covered, let me quickly take you through to the summary portion of it. And yeah, so let me just a minute. Yeah. So what we have looked into it is the association rules, affinity analysis, and market basket analysis. These kind of produce, some of the association rules between items from a database, from a transaction point of view. We have seen different measures of support, confidence, lift, and leverage, and how they are useful. And more importantly, a priori algorithm and how a priori algorithm is used to solve these kind of problems. This is needed because to reduce the computation, because when it goes beyond the 2 to the power t, where t is the number of items, unique item sets, and then it goes beyond certain very, very high, right? So that's where we use it. So that's about it. We wanted to cover association. If you have any questions, feel free to write your questions or any feedback on the comments below. Thank you so much.